Welcome to Module 2, Thinking Critically with Psychological Science. Critical thinking, I think, is the most important thing that you should develop coming out of university. Anybody can regurgitate and memorize facts. Well, not anybody, but what sets you apart as somebody who is university educated is your ability to think about material critically, and that's really what's going to help you on the job. So what we're going to do is learn what critical thinking really means. So what does it mean to think critically within the psychological science? So critical thinking refers to a more careful style of forming and evaluating knowledge than simply using intuition. In addition to the scientific method, critical thinking helps us to develop more effective and accurate ways to figure out what makes people do, think, and feel the things they do. So the scientific method helps us test it, but then we have to look at those results and be able to analyze those effectively. And we'll talk about in the next module how we analyze results and test them. But when we get something like we have a finding, so when we're reading newspaper stories, do we just take everything at face value, or do we need to think about how that's presented and what does that really mean? So why do I have to work on my thinking, you ask? Can't the professor just tell me facts about psychology? So while our brain is designed for surviving and reproducing, it's not really the best thing for seeing reality clearly. To improve our thinking, we have to catch ourselves in some of our critical thinking errors. And you might not always think that we're making errors, and sometimes, it's only by having others point it out to us that we recognize that the way we're thinking may not be the most accurate. So here are some examples of when our natural thinking styles fail. The first one is the hindsight bias, when you think you knew it all along. So a good example of this is the Penn State sexual abuse cases. I don't know if you remember those, but the coach at Penn State was accused of molesting young boys, and he was convicted of it as well, or that were in his guardianship. He was, I think, coaching them as part of his program. And once it came out, everybody said, it was so obvious that was going on all along, but why didn't anybody see the warning signs? But it's only after we find out that he is a sexual offender that we kind of look back and recognize those warning signs. Overconfidence error. I'm sure many of us have these things, like I'm sure I'm correct. It's got to be the case. And the coincidence error or mistakenly perceiving order in random events. So the dice must be fixed because you rolled 3 6s in a row. While that may be the case, often it's not. It's just really, randomly we can have 3 6s that are rolled in a row. So the hindsight bias is when you see most results of psychological research, you always say that was obvious, but it's not so obvious until after you do it, right? So it's like a crystal ball that we use to predict the past. So many times we think after we see the results that, oh yeah, that makes sense. But if we were to kind of rewind time and do that again, we wouldn't have necessarily guessed the outcome. Another type of error that we discussed was the overconfidence error. So the first one is our performance. So we are much too certain in our judgments, and we overestimate our performance, our rate of work, our skills, our degree of self-control. Like, I do this constantly when I say, oh yeah, I'm going to do this, this, and this today, and I make my to-do list. And rarely do I, get through half of it. I'm always overconfident, or I always overestimate what I'm capable of doing, even though I do this pretty much every day. The other overconfidence error is accuracy, and we overestimate the accuracy of our knowledge. People are much more certain than they are accurate. And this is a problem in eyewitness testimony, and a lot of the researchers here at John Jay do this kind of work. It's not my area of expertise per se, but you see people, saying that's definitely the guy that did it, and it was not even somebody who was even in the vicinity at the time, but they're very certain that that was the person that they saw doing it. It's also a problem on tests. If you feel confident that you know a concept, try explaining it to somebody else, because sometimes just feeling confident about it isn't enough. You have to actually demonstrate it. And that's not to say that feeling confident is not a good thing. I mean, psychologically, it's very good to feel confident, and even overconfident sometimes. I mean, it's always better to have high self-esteem than low self-esteem. However, these can sometimes impact the way that we process information. And the last error that we discussed was perceiving order in random events. So the example is the coin toss that looks wrong if there are 5 heads in a row. So thinking that you can make a prediction from a random series. So if the ball on a roulette wheel has landed on an even number 4 times in a row, it doesn't necessarily increase the likelihood that it'll land on an odd number the next spin, even though I too have been guilty of this. There's no reason why. It's just sheer luck. We just generally have a wrong idea about what randomness looks like. Another type of example of this type of error is reacting to coincidence as if it has meaning. So if a poker player at a table got 2 pocket aces, is it a rigged game? No, just by random chance it happens. And this is how superstitions develop. For example, hockey players will sometimes wear their lucky underwear because something happened when they wore that underwear. And is their underwear going to make them, more likely to win the next time? Absolutely not. But that's their perception of it because it was a random event. So how do I go about being scientific? Is there math, tests, tubes? So what you need to do is be systematic in your evaluation of all the information that you obtain, but really to guide you, you'll need to have a scientific attitude to learn how to think critically, and that's where it comes into place. So the first part of the scientific attitude is curiosity, always asking new questions. So the behavior I'm noticing in that guy, is that common to all people, or is it more common when under stress, or is it more common for only males? So the hypothesis is curiosity, if not guided by caution, can lead to the death of felines and perhaps humans. So we need to, when we are being curious, we do need to be cautious, but we also have to think about how we answer our questions scientifically. We also have to have a fair degree of skepticism. So skepticism means not accepting a fact as true without challenging it, seeing its facts, and seeing if the facts can withstand attempts to disprove them. So skepticism, like curiosity, generates questions like, is there another explanation for the behavior I'm seeing? Is there a problem with how I measured it or how I did my experiment? Do I need to change my theory to fit the evidence? So oftentimes, we'll talk about in the next module, correlation. So we see a relationship between 2 variables. So just because, the number of degrees increase in temperature outside has nothing to do with the number of, I don't know, I'm just thinking off the top of my head, the minutes of commercials that are on TV each day. Even if those 2 things might change in the same direction, they're not necessarily correlated. They just might be spurious correlations. And so we have to look at what explanations might make them. The third part of scientific attitude is humility, and it refers to the seeking the truth rather than trying to be right. So you have to, as a scientist, be able to be wrong. So sometimes the questions that you ask and the theories that you're trying to prove are not accurate, and you have to be okay with that and to be humble about it. So what matters, not in my opinion or yours, but the truth nature reveals in response to our questioning. So this is the author of our textbook. So that makes a lot of sense. And so, it doesn't matter if you're right, I'm right, but really we want to ultimately seek what is the truth. So critical thinking is analyzing information to decide if it makes sense rather than simply accepting it. So the goal is to get at the truth, even if it means putting aside your own ideas. So you look for hidden assumptions and decide if you agree. Look for hidden bias, political values, or personal connections. Put aside your own assumptions, biases, and look at the evidence. See if there was a flaw in how the information was collected, and most importantly, consider if there are other possible explanations for the facts or results. So even though you have all this data, does that mean that that's actually the case, or could there possibly be other explanations for it? So here are just some general questions that you may have about psychology, and we'll talk briefly about them. So how can the result from an experiment possibly simplified and performed in a laboratory gave us any insight into real life? So oftentimes real life is very complicated and it can't necessarily be boiled down to a simple experiment. But by isolating variables and studying them carefully, we can discover general principles that might apply to all people. And there might be multiple principles at work in human life at each time, but we can test each one of those separately and try to understand the bigger picture. Do the insights from research really apply to people, or do factors of culture and gender override these general principles of behavior? So generally research can discover human universals and study how culture and gender influences behavior. However, we have to be careful not to generalize too much from the studies done with subjects who do not represent the general population. So I do a lot of my research on students here at John Jay College using the research experience pool that you guys are participating in. but I have to take into account that you guys don't necessarily represent everybody in the country or everybody in the world. I mean, many of your experiences are unique to being in the New York City area, to being at a commuter college, to being, for example, an immigrant or a first-generation individual, for not speaking English as a first language, for example. So all those things need to be taken into account when I interpret the results of my studies. Why do we study animals? Is it possible to protect the safety and dignity of animals, animal research subjects? So clinical psychologists generally don't study using animals, but experimental psychologists will, using kind of rats, rabbits, things like that. So sometimes biologically related creatures are less complex than humans and thus easier to study, and in some cases harm to animals generates important insights to help all creatures. And so we don't take this kind of testing very lightly because we don't want to unnecessarily harm any creature. However, the value of animal research remains extremely controversial, and a lot of people disagree with it strongly, and you may feel that way as well. And so, whenever possible, we try to use simulations, and it's only when it's critical or vital to use a live creature to test some of these principles, and the methodology is not ready for testing on humans, that we would test on animals. Ethics. How do we protect the safety and dignity of human subjects? So you guys are going to be participating in research experiments. So how do we make sure that the research experiments you're participating in are not going to do any harm to you? So people in experiments might experience discomfort. Sometimes they'll be deceived, but deception sometimes yields insight into human behavior. Human research subjects are supposed to be protected by guidelines for non-harmful treatment, confidentiality, informed consent, and debriefing. So even if you have, been deceived as part of this study, you should be debriefed properly afterwards, and then explain why the deception was necessary and what was gained from it. And finally, how do the values of psychologists affect their work? Is it possible to perform value-free research? So, for example, if I have certain political beliefs or certain theoretical beliefs, my values affect my choices of topics and their interpretation. But, as a scientist, I need to think critically, and I have to put a lot of that aside and evaluate my research in an unbiased way. And all my research is subject to peer review. And so if I haven't done that, let me tell you that my peers will tell me, and they will not accept my papers for publication. So, it's virtually impossible to not have any values in your research. We try to make it as objective as possible. So this is the end of Module 2. Please again contact me if you have any questions.